Hi students, welcome to lecture 5 of week 2 of a Smart City course. In the previous lecture, we discussed the citizen participation and engagement. We saw how the citizen act as partner, censors and co-creator in the smart governance system. Citizen generates feedback, complaints, ideas and data through apps, social media and digital platforms. Now, an important question arises: once the data is generated, what happened next? How does the city converts millions of data points into the better decision? This lecture answers that question by focusing on data-driven governance. So, nowadays, data is the new oil. Just as oil powered the industry economy, data powers the smart city. Every day, citizen generates massive volume of data from sensors, cameras, mobile phone, and governance digital platforms. This data is characterized by the volume, velocity, variety, and veracity. It refined properly, the data becomes a powerful assets to the governance, and it's a strategic governance asset. Traditionally, the governance relied on experience and intuition. However, nowadays, modern cities are far too complex for intuition alone. Data-driven governance replaces all these kind of assumptions or intuition with the evidence and enables proactive decision making. Urban data originates from multiple sources. Whatever the sensor you have employed, that sensors capture the physical conditions, citizen platform capture live experience, administrative system record whatever the transitions, and social media reflect the public sentiments. Together, these sources create a comprehensive picture of the city. The raw data what we have does not have any value by itself or have very limited value. In order to make data actionable, we need to follow a DIKW pyramid approach, in which whatever data we have, that data should becomes information first, and then it should be treated with knowledge, and then through wisdom in order to make a sensible decision or sensible action based on those data points. So through analysis, data becomes information, and then knowledge, and finally the wisdom. This is known as DIKW pyramid. For example, the traffic speed data reveals congestion pattern, which support a smart signal timing decisions. So if you have the congestion data of any road, any network, then you can alter whatever the traffic signal timing, that means the phase cycles of a particular signals in a traffic or in a network. In a smart cities, data follow a life cycle. The first stage in this life cycle is the generation of the data, and then the next stage will be storage and management. The other stage after this will be analysis and modeling. Then there will be action based on this analysis. The weakness at any of these stages can reduce the governance effectiveness. A strong life cycle management ensures timely and reliable decision. The data could be of two types. One could be the structured data and second could be unstructured data. Some urban data could be structured, such as the billing records of maybe the electricity bill, maybe the telephone bill, maybe any kind of these kind of bills. However, the most urban data what is being there is unstructured. such as your video or text. Managing unstructured data is one of the biggest challenges in the smart governance system. So in order to make the data more structured, there are different types of analytics which can be used. The analytics converts data into insight. Descriptive analytics shows what happened. Diagnostic analytics explain why it happened. Predictive analysis forecasts future events, and prospective analytics recommends the action which need to be taken for these type of data. Dashboards and KPIs support descriptive analytics. Diagnostic analytics identifies what is the root cause of any kind of problem. Together they provide transparency and accountability to the e-governance system. Predictive analytics help anticipate conjunctions or flood or any kind of event based on the data points collected, what is going to happen in the future. Prospective analytics goes further from the predictive analysis. It triggers automated responses such as the adaptive traffic signals or what steps need to be taken when flood is going to occur. So these all things will happen in the prospective analysis. There are two types of data curation techniques. One is the data lake and second is the data warehouse. The data lake stores data in the raw format. However, the data warehouse stores data in the curated data format. The smart city requires both for flexibility and reliability. The urban dashboard summarizes what performance of the city is actually happening in the real-time basis. Like what is the traffic scenario at the present time, what are the areas which are congested, what is the signal timing at the present in the city. These all information will be summarized in the dashboard and will be displayed in your integrated command and control center. When this information integrated with GIS, they provide spatial context, helping administration understand where exactly on the coordinate basis, where exactly these problems are occurring, and measured action can be taken quickly. Urban data observatories focuses on long-term indicators such as quality of life. They support strategic planning and intercity benchmarking. Open data treats non-sensitive government data as a public resources. It improves transparency and enable innovation, such as new startups which are coming today, or some other third party, maybe some researchers sitting on some university, maybe in India and abroad, can take those kind of data and do their own analysis and may innovate and may suggest some innovative solutions to a particular problem. For an example, like public transport GPS data in a common open data example, third-party application use this data to provide superior mobility services. Large-scale data collection raises privacy concerns. Therefore, anonymization and purpose limitations are essential to maintain trust in the data. Data security is nowadays major concern because lot of data will be collected from the citizens app or citizens tool. Lot of the data from the videos form or other format will be collected. So data security is now a major concern. The security of the data relies on confidentiality, integrity and availability. The failure of any pillar undermines the governance system or e-governance system. India's Digital Personal Data Protection Act governs data usage. It emphasizes consent and accountability of the data. So whatever the data is being collected from you, they are protected from the India's Digital Personal Data Protection Act. AI system can be biased or opaque. explainable and responsible AI is essential for the public trust. Challenges include the data silos, legacy system, and skill gap some are the main challenges coming for the digital governance. Some part of this we have already seen in our previous lecture. The institutional reforms are required to address them. Whatever the data we have collected, that data needs to be converted to the action. The real value of data lies on action only. The analytics must translate into decisions with automation supported by human oversight. To conclude this lecture, we have seen the citizen generated and sensor data from the foundation of the smart governance. Analytics transform data into the decision. Ethics, security, and trust must guide all the data-driven initiatives. So that's it for this module. Thank you so much.